In the previous lesson, we talked about measures of center, and mainly we focused on mean and median. And now we're going to talk about how we can discuss how the data is spread out, how it varies. And we're going to start with the two main ones, interquartile range and standard deviation. We're going to be looking at the properties of each and some misconceptions about variability. Studying these measures will also lead to an important result, which is the empirical rule, which is something that you definitely will need to memorize. And an important technique, which is standardization. And we'll see those, they'll pop back up very, very often throughout the course. So, when you've talked about spread of data in the past, you've looked at just the range, the overall range of the data, which was like the largest minus the smallest, the max minus the min. Well, that doesn't tell you too much. I mean, that just tells you the biggest minus the smallest, and that's not resistant. I mean, if you have an outlier, that really is widespread. But if we can narrow it down, we can get a little bit more of a feeling of how spread out the data is. So what we're going to be using is what is called the interquartile range. So instead of just looking at the data overall, we're going to divide the data up into quartiles. So interquartile range is found by looking between the upper quartile and the lower quartile. So let's look at that. That means we're going to divide the data into force. The 25th percentile, 50th percentile, 75th percentile, first quarter, second quarter, third quarter. So if we thought about the data spread out, let me do a little visual here. Let's say, I listed all the data out like we would if we were finding the median. And here's my smallest. This is the minimum here. And over here is the maximum. So 100% of my data is between here and here. So, if I were to take the max minus the min, this is the range, right? Overall range. That's the big range of our data. Now the median is right in the middle, right? 50% is on the right and 50% is on the left, half and half. Well, that means that this is technically quartile 2. It's halfway throughout. So quartile 1 would be halfway between the minimum and the median. This would be quartile 1, and I abbreviate it with Q1. And quartile 3 would be halfway between the median and your maximum. In other words, 25% of your data is right here, 25% is right here, 25%, if you listed out all the numbers, and 25% is right here. Quarter, 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 quarter. Your interquartile range, interquartile, is between Q1 and Q3. You're looking at the data right around the center. So let's think about how we would find that quartile. We would do just what I said. We would arrange it like you would if you were finding the median. You'd arrange it in ascending order. You would determine the median. And then you would go halfway between the beginning and the median, and then halfway between the median and further. And yeah, and it takes a little while. And so if we had very few data, it doesn't take, we could do it. I'm also going to show you how to do this in the calculator because, we could list all the data and blah, blah, blah. Calculator does this as well, and so it kind of makes it a little bit easier. So I'm going to show you how to do that. So we've got some data here, and this is the Highway Loss Data Institute routinely collects data on collision coverage claims. Collision coverage ensures against physical damage to an insured individual's vehicle. The data in the table below represents a random sample of 18 collision coverage claims based on data obtained from the Highway Loss Data Institute for 2004 models. Now, we could list them all out. I'm going to show you how to do this a lot faster. So, in your calculator, if we go in, so if we press stat, so I'm gonna put the instructions up here. Stat. Oops. So press the stat button, and we're gonna edit, and we're gonna put the data into L1. And you don't have to put it in order, you can just actually type it straight in. Now, if you wanted to do it by hand, you could you would list them out in order from smallest to largest. And then you would find your median, and then the median from the middle. Whoops, messed up on that one. 4668. Okay, and I think I've got them all in. Once you have your data in the list, you'll press stat again, and then arrow over to the calculate menu. We're going to be using this menu a lot. So stat, and then arrow over to calc. We're going to go to one variable statistics. And we'll talk about a lot of the things that are in there. So I'm going to press enter, and then it asks you some questions. Is your list in L1? Yes. Do we have a frequency list? This is used if your data was in a table and your data was shown like several times. You need frequencies of it, but we don't have that. And it gives me a whole bunch of stuff, and we will be learning about all of these symbols as we go through. But the first symbol we should recognize is that X with a bar over it. That's actually the sample mean. So it does give me that. I'm going to write that down. The sample mean, because this was a sample, it adds them up and finds the average for me. It also gives me N, which is the number of values. We will be using all of these other ones in future data, but the ones we're going to be looking at next are these next 5 things. It tells me min X is 180, Q1 is 735, MED is 1805, Q3 is 4668, and max X is 21147. It has just given me what is called a 5-number summary. Five-number summary. This is the minimum. This is that quartile 1, the median, quartile 3, and the max. So I can find my range, my interquartile range, and everything. So let's talk about what these quartiles mean in terms of percentages. So the Q1 is 735. What that means is 25% had claims between $180, between that minimum, and $735. Q2, which is the median, means we had 50% had claims between $180 and $1,805. Q3 means 75% had claims between $180 and $4,668. Now let's look at the interquartile range. So IQR, that is taking Q3 minus Q1. So the 4668 minus 735. Whoops, 735 is 3933. What that means is there is a difference of $3,933 for the middle 50% of claims. Now think about that. Between the min and the median, it's only $1,700. And then the median to here is only like $1,400. But the middle 50% is $4,000. I mean, that's a lot. I'm sorry, this is a lot more than that. There's a big jump between the median and the max. So only $4,000 of it is in that middle 50%, right around that center. So that kind of tells me that we've got a big jump after quartile 3, right? Because the overall range, if I was just looking at the overall range, which is max minus min, that would be, 21, okay, so if I took the max minus the min, that's an overall of $20,967, but only 4,000 is right there in the middle. So you start thinking, maybe there's a way to use that IQR to talk about outliers, and there are. So we'll get to that in a little bit. But we're talking about those percentiles, and that's a big deal. So those quartiles are special cases of percentiles, and we'll be dealing with those later too. Percentiles, you see that a lot when you talk about SAT scores. You want to be in the top 90 percentile. That means like 10% are above you, 90% are below you. That's another way we can talk about the spread of the data. The next one that we're going to talk about real quick, though, is standard deviation. Standard deviation is the other way to talk about the spread. Now, so IQR is talking about how far away we are from the median, like it's that middle 50%. Standard deviation is more of talking about how far away we are from the mean. So standard deviation is used with mean. Okay? So I want to show kind of an example. This kind of shows how mean and standard deviation work. So let's say we have a set of numbers, 100, 100, 100, 100, 100, 100. Well, the average of those is 100. The deviation is 0. They're all the same. Now this set of numbers also has an average of 100 with a standard deviation of 10. So the spread is 10 points away from that average of 10. So when we talk about standard deviation, we're talking about how far away things are from the mean, from the average. Now, this can be found in the calculator as well. There is a way to calculate it by hand, and so I do give you the formulas for finding the population standard deviation and the sample standard deviation. If you're going to do it by hand, you would calculate the mean, and then for each value, you would find the difference between that data value and the mean. So this shows me finding the difference. So the data value minus that average, the mean. You would then square each of those differences. So that's what it says, squared. This weird symbol here means to sum them up. Add them all up. And then divide that. If you're doing the population, you would divide by the number of the values in the population. If you're doing it for the sample, it's the number in the sample minus 1. And then we take the square root of it. Now, in my class, I'm fine with using the calculator for everything. And so both of these are found in the calculator in that one variable stat. This one has, this is a lowercase sigma x, and this one has an s with an x. So it does find those for us. So if we looked back at what we did earlier, if I up arrow, it does give me my standard deviation for the sample was 5,301, and the standard deviation for the population is 5,152. So it does actually calculate those for us. There's also something called the variance. The variance is just that standard deviation squared. So the standard deviation, whatever we got for standard deviation, and we would just square it. So we're just gonna find those real quick. We're gonna practice finding each of those values. So we have data representing the first exam of 10 students enrolled in introductory statistics, and we are going to find each of these values. So I'm going to show how to do it all in the calculator. So we would go to stat. Now the quick way to clear out a list in your calculator is to up arrow to where the L1 is highlighted, then press clear, enter. Don't press delete because it will delete the list instead of just clearing it. And then you would type in your data. Then we're going to press stat again, go to calculate, and then one variable stats. This time I'm going to write out everything we see, and we're going to talk about what we have and list out. So I'm going to actually write down everything we have. and we'll write out to, whoops, 7.4. I got dyslexic there. We can do so much with what is just given to us with this list. So this first one is our sample mean. Very important. Now this just means sum of all the x's. It just means if I added up all the data. This means sum of x squared. It just means if I squared each one of them and added it all up. That could be useful in some formulas. This is the sample standard deviation. And this is the population standard deviation. This is the number of values. And this is that 5-number summary that we found before. So I've got my median, got quartile 1, quartile 3, all those good things. So, compute the range. That's max minus min. So for range, max minus min, the max was 94 minus 62, that gives me 36. We could also compute the interquartile range. That's quartile 3 minus quartile 1. 88 minus 71. Now I want to look at the variance and the standard deviation. Now this is just of 10 students enrolled in a section, so that we're talking about a sample. So for standard deviation, I want the sample, which was 10.35. Variance is just the standard deviation squared. So I'm just going to take that 10.35 and square it. You may be asking yourself, what are these telling me? So standard deviation is really just telling us how far away from the mean our data is. Variance is a little bit harder to explain intuitively. It's the degree of spread for the whole data set. So the higher it is, the more spread out the data is. We usually stick with standard deviation when we're talking about spread because it's really saying that most of our data is around 10 away from the mean. And that kind of makes sense if you think about here. So even with the median, the median was 79.5 and our quartile was 70 to 88. So we're around 10 around the median. the sample mean was 79, and most of these values are around 10 away from 79, between 69 and 89. That's more of what we want to focus on, is the standard deviation. So what I do want to make sure we know is that standard deviation goes with mean. Standard deviation and mean go together. And let's see how they really go together. And that's with the empirical rule. So, empirical rule, we're going to dig deeper into this standard deviation thing. And it says, the empirical rule says that if we have a normal distribution, that means if I look at the picture and it's a nice, pretty, bell-shaped, normal distribution, it's not skewed one way or another. It's nice and pretty. 68% of my data will fall within one standard deviation of the mean. 95% will fall within 2 standard deviations. And 99.7% will be within 3 standard deviations. That's the empirical rule. And it's beautiful. I mean, what that means is if this is my mean, and this is showing the population here, population mean being in the middle. If I go 1 standard deviation, another standard deviation, another standard deviation, 68% of my data is right here in the middle, within 1 standard deviation away. That means 34% and 34% are right there. 68% is right within 1 standard deviation of that mean. And then 95% are within 2 standard deviations. That's a lot. You need to know these percentages. 99.7%, that's almost everything, is going to be within 3 standard deviations. That's a bunch. Suppose we have a bell-shaped curve with a mean of 25. So we've got this lovely, perfect, mine's not perfect, but that's okay. Let's pretend it is. Right in the middle. Whoa, I can't draw straight today, is the mean. So 25. Standard deviation of 5. So if I go out 5 steps each way, that would make this 20 and 30. 68% of the data is right here. If I go out 5 and 5 more, standard deviation of 5, standard deviation of 5. So this would be 15 and this would be 35. 95% is right here. And if I go out 5 more, 10 and 40, 99.7% are between 10 and 40. That's the empirical rule. And we're going to be coming back to that empirical rule a lot throughout this course.